Lesson 6.6. We are, short of it, solving equations. Okay, so we're taking everything we've learned in this chapter and using it to solve equations that are, for instance, like this one, the exponential form. Or we'll also talk about some log form equations. Okay, so the front page, we're pretty much looking at exponential equations. Now, I haven't broken them into a top half and bottom half because there's kind of two different ways to solve depending on what you can find. I should have also told you to get your gold papers out because those will be helpful today too. The goldenrod half sheet papers. Goldenrod, orange, yellow, gold. Yeah, no. The ones that look like your blue papers from last chapter. Okay. Now, as we look at this first set here, okay, we are solving exponential equations. Now, you'll notice the title of this lesson, or this section, is Solving Exponential Equations with a Common Base. So solve each equation using a common base, meaning we can get a common base. Okay, so look at your bases. My bases right now in the first example are currently 25 and 125. Okay, this is where the gold paper is going to come in handy. What do 25 and 125 have in common? Like, how can we rewrite these in terms of powers or exponents and use the same base? How can we make this happen? Okay. If you look on your paper, 25 and 125 both fall in your 5 list, don't they? Okay. That's what you want to look for, is numbers where they fall in the same list. So that's what we're going to do. We're going to rewrite this in terms of the base 5. So 25 is 5 to the second according to the paper, right? So for the moment, I'm going to write this as 5 to the second raised to the 3x equals, and what did you say about 125? That is 5 to the third raised to the x plus 2. Okay, so the idea here is I can get these both with the same base. Now, first of all, what's the rule? What do we do when we're raising a power to a power? So we have 5 to the second. We're raising it to the power of 3x. What do we do with that 2 and that 3x? We're going to multiply. Okay? You're thinking when the bases are the same.
Yeah.
Okay, so for difference sake, right? Right there, if the bases are the same, you keep the base of 5 and you would add. But this is a base raised, or a power raised to a power, so we're going to multiply. So this is going to be, on the left, it's going to become 5 to the what? 6x. On the right, same thing. It's a power raised to a power, so we're going to multiply. So it's going to become 5 to the what?
6 plus 6. 3x plus 6.
There we go. 3x plus 6. Because what did you basically do? You took the 3 and you distributed it, yes? Okay. Now, trying to think if we've done this or not. I feel like maybe we have. The bases are the same. They're both base of 5, yes? What should that mean about the powers?
They're the same.
They're the same, right? Think logically here. If it's 5 to some power equals 5 to some power, those powers have to equal. So what we can do to finish this problem off, drop off your 5s and set up the equation 6x equals 3x plus 6. And solve this middle school level equation.
Subtract that from that 3.
Okay, you want to get your x's together on the same side. So we're going to subtract over the 3x. 6x minus 3x is 3x. 3x minus 3x cancels, leaving me with 6. Okay. If it's 3x equals 6, we're going to divide by 3. And x is 2. Okay? So anytime we're working with exponential equations, my suggestion is always going to be, can you get a common base? Because if you can get a common base, that's pretty, not too difficult algebra, right? We've seen a lot harder stuff, okay? So that's going to be my suggestion there. Okay. Questions there? Okay, let's try B. You have some hints because we're still in this section here, right? So think about how you can get 1/2 and 4 to rewrite them with the same base. Now 1/2 you're not going to find on this paper, are you? We don't have fractions on our gold paper. But what's in the denominator there? A 2. So let's revise this to, what about 2 and 4? Can you write them with the same base?
2 squared, 2 first.
Okay, 2 is 2 to the first, 4 is 2 squared, yes? Now, keep in mind, this 2 to the first, I'm going to put a little 1 in there. I don't know if you guys can see that from where you're at, but it's 1 over 2 to the first. How do I make this just a 2 that's not in the denominator? Yeah, make it a negative. So 1 over 2 to the first is the same thing as saying 2 to the negative first raised to the x plus 7. Okay, lock in on that. Whenever you see a fraction, there's going to be a negative exponent involved. The negative exponent is going to be what gets you out of that denominator. So we have 2 to the negative first raised to the x plus 7. What did you say about 4? 4 is 2 to the second. So I have 2 to the second raised to the 3x. Okay. Was I able to get the base the same? Yeah, okay. So let's deal with a power raised to a power. How do we deal with a power raised to a power? We're going to multiply. So on the left, I'm going to have 2 to what? What is negative 1 times x plus 7?
Negative 1x plus
Minus 7.
negative 7. Also minus 7
Okay.
plus.
I wrote it, final form, as negative x minus 7. Other things are correct. You say negative 1x minus 7, negative 1x plus negative 7. Those things are equivalent. On the right, what do we have? 2 to the what? 6x, because we're multiplying, right? Power raised to a power, you're going to multiply. Bases are the same, so what are we doing?
Drop it.
Drop the bases. Set your exponents equal to each other. Negative x minus 7 equals 6x.
Add this 7 over. Nope, add the x over.
Different. We could go a couple different ways here. Since we already have a 6x by itself on the right, could we add this x over to join it? Certainly can. So negative x plus x cancels on the left. I have negative 7. On the right, 6x plus x. 7x.
1.
And if it's 7x, to get x by itself, we're going to divide by 7. And what is x? Negative 1. Okay. I haven't really talked about checking our answers thus far today. And I'm not going to really at this point. I will later on in this lesson. Because if you go back to the original equation, these are just plugging into powers and whatnot. And you can have negative powers. Okay. When we get to logs, we'll talk about we need to check things because we don't want negative logs. But this is fine. Okay. C. I'm going to be lazy like you guys and read it as 0.001 equals 10 to the 6th x.
1%.
What is 0.001 said properly in math? I mean, we get lazy and say 0.001, but it's what? It's one,
It's 1,000.
right? Tenths, hundredths, thousandths. So it's 1/1000. Now, put that as a fraction. 0.001 is 1/1000th. I'm trying to lead you somewhere. And I guess I probably messed up because I probably should have asked, does anyone see the connection from the beginning? But there is a connection here. We can use, well, we can use the idea of our gold paper. I guess I'll put it that way. Is there a base we're going to be able to get these to both have?
Ten to the first, 10 cubed.
Okay. On the right, we already have 10. 10 is 10. 10 is 2 times 5. There's no way to write it with exponents, okay? 10 is just 10. But 1,000. A 1 with 3 zeros is 10 to the third power, right? That's stored away deep down in your memory somewhere, okay? I know it is. It's deep, okay? But I know you guys know. So this is 1 over 10 to the third. Does that work for us? Are we going to be able to make this happen? Yeah. What do we know about 1 over 10 to the third? It's going to be a negative, right? So this is 10 to the negative third equals 10 to the 6x. Okay. You got the next answer, or you got a question?
I think I have. Okay, so what if? So does x equal -1/2?
I don't know. I'm not there yet.
All right.
Come back to me here in a moment.
All right.
Okay. What's my next step here?
Dropping the tens.
Okay, my bases are the same, right? So we can drop the tens, and we have -3 equals 6x, yes? How do we solve for x?
Divide by 6.
Divide by 6. And when we divide by 6, what about -3 divided by 6?
-1/2.
It reduces to be -1/2, doesn't it?
Yeah.
Or if you wanted to say -0.5, I would accept that. Okay, now did you have a question to go along with this, Ashley, or?
Oh yeah, I was just announcing that I found the answer.
Okay.
Because I like these kinds of questions where you just have to solve for x and like make the two things match. Match because like I kind of have like my own way of doing them.
Okay, well, and here's what I'm going to say. I know we all have our different versions of how we might do things, but make sure you learn the steps with me, okay? Make sure you learn the steps with me, because knowing the steps is going to help you be able to solve all problems, even the difficult ones, okay? Okay, so this section up here, we could get a common base, we could use that gold paper. Anytime you see exponents, that's the first thing I'm going to have you check, okay? Are we ready for the next section? Okay, in this next section, okay, the title gives it away. Solving exponential equations with different bases. Okay, and then on top of that it says solve each equation using logarithms. That's giving you a hint of where we're going. And it also tells us to round to the nearest 10,000th. So you know we're not going to get the nice, neat whole number answers we were getting in the last section, were we? We're going to be talking decimals here. Now, here's what I'm going to suggest when you're working on a quiz or a test or you're working on homework. I'm going to, because they won't necessarily say if the common bases can be gotten or not. The first thing I'm going to say, though, 3 and 15. Can you rewrite 3 and 15 with the same base from the gold paper?
No.
And keep in mind, 3, the only way to get 3 is 1 times 3. I mean, if we're sticking with whole numbers, I'm not going to go the decimal route. Okay. 15, okay, it's 3 times 5. But do any of these involve powers?
No.
No. Nothing involves powers like where it's 3 to the first, 3 to the second, things like that. So we have to have a plan B. And this is where plan B comes into place. We can't get the same base. So this is where we're going to take the log of both sides. And we're going to work from there to solve for x. Okay, now, taking the log of both sides, first of all, you need to have the power by itself. We already have 3 to the x by itself, yes? So you need to have the power by itself. Taking the log of both sides just means writing the word log in front of each side. Okay? So I'm going to rewrite this. Of log of 3 to the x equals log of 15. Okay? That's what I mean by taking the log of both sides. Now, our job is to solve for x, yes? Where is my x?
The exponent.
It's in the exponent. We learned a rule the other day. How do I get that x out of the exponent?
Left, right.
No?
Oh.
I have logs on both sides, thus I have to decline left, right, middle. This was the first day of lesson 6.5.
You put it, the exponent in the front.
Yeah. You guys remember the power property from the beginning of 6.5? The power property says the power on a log can be moved to the front of the log as a coefficient. So I'm going to rewrite this as x times log of 3 still equals log of 15. Okay? Now, with that in mind, folks, we just have one more step to solve for x. Thoughts of how I solve for x or get x by itself? Okay. How are the x and the log 3 currently together? It's x times log 3, yes? So how do you break apart multiplication? You divide, right? To break apart this multiplication, we're going to divide. If we're wanting to get x by itself, what do we divide by? Log of 3. Well, you know what's coming next. If you divide the left by log of 3, you're going to divide the right by log of 3. Folks, grab your calculator and finish the problem off. In other words, you're putting into your calculator log of 15 divided by log of 3. Whatever that is, you're there. And how many decimal places are we going? Tenths? Hundreds? Thousands? 10,000ths? So we are going for 4. So what are 4 decimal places? 2.4650. Am I guessing we had to round that?
Yeah.
Now, do I need to show that on the calculator, or did we get that? Are we good? Because I can show it on the calculator. At this point, I feel like we're, you guys know how to push the log buttons on the calculators, right? So what was it? Log of 15 divided by log of 3. Just make sure you put the parentheses after the 15. That's going to be required. So 4 decimal places, 2.4649. 7 tells the 9 to go up, right? Well, when that 9 goes up, really just think of what goes up from 49. And that's 50, yes? Because the 9 is part of 49. So, or the 9 goes up to a 0, and now we bump the 4 up to a 5. However you talk about it. Okay. So that's your plan when the gold paper fails us and we can't get our log bases the same. Okay? That's your plan. So let's try this next one. Now, as I mentioned earlier, in order for this to work, we need powers by themselves. Which means what should be my first step here?
Moving this 6. Oh, well, yeah.
Move something. What are we going to move? Well, if I want to get the piece with the power by itself. So I want to basically get the 5 to the 6 minus x by itself.
Subtract the 4 over.
So we're going to subtract the 4 over. Since it's a positive 4, we subtract 4. And so now I'm at the 5 to the 6 minus x equals 11. Okay. I'm always going to try and get you guys to pause and think, can 5 and 11 be rewritten in the same base? No, 5 and 11 are both prime. That's just 1 times 5, 1 times 11. They don't have other factors, so nope, we're stuck. So what am I going to say then?
Take it.
Okay.
Log 6 minus x log 5.
Okay. So we're going to take the log of both sides, right? Which is just me writing the word log in front of each side. So log of 5 to the 6 minus x equals log of 11. Now, of course, this one gets a little fancier, right? You know, we can't keep them the basic one-step problems every time. Okay. You know the next step, though. What do we have to do? Okay. We have to move the power out front. We have to get that x out of the exponent. So 6 minus x is going out front. Now, when I write that 6 minus x, it's more than one term. So I'm going to write this as 6 minus x in parentheses times log of 5 equals log of 11. Now, sorry, I'm staring at my notes for a moment because I'm trying to decide which way I want to go. And maybe I'll let you guys decide. Our job is to solve for x. There's 2 different ways to proceed that would both work. This is where I was just trying to decide what do I want to suggest, or do I just want you guys to figure it out? So thoughts of how we're going to solve for x here? No? We are going to solve for x, just so you know. We don't get out of it. That is one option. Here's the deal. That 6 minus x is currently being multiplied by log 5, right? One option is you could divide the log 5 and thus move it to the other side, yes? And then you have 6 minus x, and you're trying to solve for x, yes? Okay. The other option, this is where the other option is log 5. Now keep in mind, log 5, it's a number, yes? I don't know what the number is. My calculator knows the number. I don't know what the number is. But log 5 is a number, yes? Your other option is distribute. Take the log 5 and distribute it to the 6 and distribute it to the minus x. Okay? Now, as I said, I was trying to decide which I wanted to do. What I'm looking at later on we're going to have to distribute. So I'm kind of thinking about leading us towards distributing. I don't know. You guys are like all of a sudden deathly quiet here. We don't know what we want. You gonna make me decide? Like I'm the teacher or something? Okay. So in this situation, I don't mind the idea of dividing by log of 5. And I don't mind it because there's only one x and it's right here, and that'll make it makes it work. Do we want to try that then? Are you guys not liking the idea of distribute? Okay, well, we can go this way. We can divide. I'm going to have to show you distribute down later. I have to. Okay? Because later we'll have x's on both sides. So that distribute comes into necessity. But if you don't want to distribute here, okay. It's 6 minus x times log 5. To get the log 5 out of there, I'm going to divide by log 5. Now, on the left, the log 5's cancel, yes? And I'm left with what? 6 minus x. On the right, log 11 divided by log 5 is some lovely decimal that your calculator knows, yes? Here's what I'm going to do. I'll get the decimal later, if you guys don't mind. Okay? Just log 11 divided by log 5. It's a number, right? Just think of it as a number. How do we solve for x? How do I get x by itself here? Tweak that a little bit. Okay, it's a positive 6, so if I'm going to move the 6 over, I would have to subtract the 6 over. Fair enough? Okay, so now I have negative x equals log of 11 divided by log of 5, whatever that number is, minus 6. I don't know it yet. We'll figure it out. What else do I have to do to get x by itself? Get rid of the negative. How do you guys want to get rid of the negative? Okay. Divide by negative 1. Is that an option? It is. Do we have x by itself now? We do. So what do we do to finish this off?
Log 11 divided by 5 minus 6.
Okay. So I would recommend doing this in parts. On that last quiz, folks, some of you had issues with your graphs and stuff because you didn't plug it into the calculator right. So here's what I'm going to recommend. Don't try and plug everything into the calculator at once. It was getting people in trouble. Piece it. Do small bits. So let's worry about log 11 divided by log 5. Does that make sense? Log 11 in that parenthesis divided by log 5 into that parenthesis. Okay, first one has to be, the second one in. Okay, that decimal is that 1.489 number, yes? Now what do we have to do?
Divide by 6.
Subtract 6, and again, I'm going to hit equals. Now I'm at negative 4.5 something, yes? Then I'm going to divide by the negative 1. Which, yeah, it just flips it to positive. Not that you're going to have to push that in the calculator. So, are you guys okay with that? Okay. Take it in small pieces. What are we doing? 4 decimal places? So, 4.5101. Okay. That's one option, folks. You're going to see the distribute option soon enough. The distribute option would have been another option. This works, though, because there was just one x we were trying to get by itself. So we were just gradually moving everything away from it. Okay? Nice thing is you get to punch in the calculator, right? You don't have to do a bunch of math on your own. You just have to punch in the calculator. You have to know the steps, though. Are you seeing how it's just like solving regular equations, though? You just have these logs in them that make things look uglier, but your calculator takes care of it. Okay, you ready for number 3? Number C? Letter C? Yeah, whatever. Okay. On C, 3 to the x plus 1 equals 5 to the x. Take a guess. Can we get 3 and 5 to have the same base? No, of course not. So what are we going to do? We're going to take the log of both sides. So I'm going to rewrite this. Log of 3 to the x plus 1 equals log of 5 to the x. After you take the log of both sides, what do we do now? Okay, move your powers out front. Okay, use that power property. So now, on the left, when I move x plus 1 out front, realize that's more than one thing. I'm going to put x plus 1 in parentheses times log of 3. On the right, when I move the x out front, it's just x times log of 5. I don't have to have that one in parentheses. Okay? Okay, guys. Our job is to solve for x. What's different about this problem? There's 2 x's, right? We have x's on both sides. And that's what makes this one different. Okay? Because we have x's on both sides, is there an advantage to dividing by log 3 similar to what we did last time? Yes and no. The problem is we have that x right there, don't we? And since we have an x on both sides, we're not going to be able to easily just divide that. We're going to have to play the distributive game. Okay? So what do I mean here? If this is x plus 1 times log of 3, what are we going to do? That log of 3 multiplies by both terms in the parentheses. Okay? It's just like saying what's x plus 1 times 3, which is 3 times x plus 1. Okay, we're multiplying that log 3. Now, what is log 3 times x? Except I'm gonna write it as x times log 3, because not that she meant it, but Olivia just said log 3x. That's different. Okay, it's not necessarily what she meant, but that's different. So I'm going to keep my x out front, and it's x times log of 3. Plus, what's 1 times log of 3? Yeah, just 1 log of 3 or log of 3. On the right, I still have the x log 5. Okay. We're trying to solve for x. We need the x's where? Together. How do I get the x's together? We need them on the same side. I have an x term on the right. Can I make this x term move to the right? Yeah. Okay. How can I put both my x terms together on the right? In other words, how can I make x log 3 move to the right? It's being added to the other term, so I'm going to go with subtract, right? So we're going to subtract x log 3. If I subtract x log 3 on the left, I'm subtracting x log 3 on the right. What remains on the left then?
Log 3.
Log 3. On the right, we're going to have x log 5 minus x log 3. Now, did you know I can't subtract those? Log 5 and log 3, they don't subtract. They don't have the same insides. Logs just don't really subtract. Okay? They get rewritten as division problems, but they don't subtract. Okay. Where are my x's? They're both on the right side, yes? Both terms on the right have an x in common, correct? Okay. What if I throw the word or the phrase GCF out? Both terms on the right have a GCF of, what do they both have in common? X. Just x. Log goes with the 5 and with the 3. So we're going to factor out the x here. Okay? We're almost there, guys. I promise. You're going to know what to do after this. So log 3 stays log 3. On the right, because both terms have an x, I'm going to factor that x out. So I'm going to put the x out front. What remains when I factor the x out? Log 5 minus log 3. Okay, guys, home stretch. On the right, that is x times what's in the parentheses, yes? Okay, don't get hung up by the ugliness of it. If it's x times something, how do you get x by itself? Divide by something, right? The opposite of multiplying by something is to divide by something. What was the something we're multiplying by? That is the log 5 minus log 3. Now, I am going to put it in parentheses because it's two terms. But we're going to divide by the quantity, log 5 minus log 3. You can do that. It's in parentheses. It's x times that. That means we're dividing this side by log 5 minus log 3. Guys, parentheses. Did you put them down? Not just think, oh, I hate parentheses. I'm not going to bother writing this. They mean something here. They matter. Grab your calculator. What do we, and I'll go ahead and write out, what is it we're going to be plugging into the calculator? What do we have to do? Log 3 divided by log 5 minus log 3. Now, and this is where I'm going to say, not that you have to have parentheses on the bottom when you're writing it, but they're going to help you get the correct answer. Okay, there's more than one thing going on in that denominator. So, anytime there's more than one thing going on in the denominator and the numerator, you need parentheses there. So are you with me here? I'm going to do log of 3 on top, yes? I'm going to end my parentheses for the log 3. Divided by. Now, here's the deal. I have two things being subtracted on the bottom. What do I have to start my denominator with? Parentheses. Then I'm in those parentheses, log 5 in that parentheses, minus log 3, technically in that parentheses and in another one. You don't even have to end the parentheses in that at that point. Did you get my answer? That means you entered it right on the calculator. So 2.1506, but the 6 is going to round up to 2.1507. Am I right in saying that? Okay. Your other option, if you didn't like all the parenthesis work, okay, here's the other option. Could you find log 5 minus log 3 to begin with? Right? So here's another option. You find log 5 minus log 3, so you find that denominator. Now, this is my most recent answer on my calculator, yes? So I can do log 3 divided by, and then I can do second ants. I think I showed this the other day, or maybe it was in a different class. But I could do second ants where I'm using my previous answer down here, and that would get me the answer too. Okay? It's an option. Learn how to work the calculator you use. Whether it's yours or mine, learn how to work it, because there are some good tricks. Okay. stopping point for today. Tomorrow we'll finish this one exponential, and then we'll do some log equations on the back, and go from there. End of the 9 weeks is tomorrow. Skyward is as up to date as I know it should be, unless you finish something during homeroom that I haven't updated. So, if there's any zeros in Skyward, get them taken care of.